without further wait, we'll get started. Okay, so the agenda, what we're going to review today, our story, some end users, electrical safety, the standard, which is the most important and critical thing that we're going to talk about today, approach restriction, types and causes of arc flash, clothing, gloves, and tools. I'll mention right now that this is not a, this is meant to be a very broad stroke on electrical safety in general. We're talking about arc flash today. But ultimately, if your facility needs a presentation or a site assessment, that's something that you have to look further for. This is actually a presentation that's about 4 hours long, cut down into a half an hour segment. So our story, some of you that might know us as Catalyst Sales and Marketing, we're an agency working with or in the electrical wholesale industry. We cover a very broad spectrum of electrical products and safety. As an agency, we connect global manufacturers to local markets. In regards to arc flash, over the years, these are some of the facilities that we've supplied product to. But I mean, looking further than this, in every city and town in Atlantic Canada, you wouldn't have to go too far to find an electrical contractor that would have gloves or suits that came through us. So what's an arc flash? So an arc flash is light and heat produced from an electric arc supplied with sufficient electrical energy, and that can cause substantial damage, harm, fire, or injury. As an arc develops, it gets hotter, and then the resistance drops. This draws more current, and we have what's called a runaway. And the runaway happens if there's nothing there to fuse it or blow. Some part of your system is either going to melt, trip, evaporate, or just explode. Probably the purest form, or the simplest form I can think of that, and I don't think anyone's too young to remember incandescent bulbs, but probably the purest one that you may have actually seen is when you see a light bulb blow. That is a very small arc flash. The tungsten filament gets super hot in one area. It overcurrents, you have that runaway, and then it goes to extreme bright white light, and then poof, it's out. So back in 2008, CSA introduced this standard, which is the Z462, and it pertains to workplace electrical safety. It was written in conjunction with NAFTA 70E, and the NAFTA 70E is the United States version. So if you're compliant with one, you're compliant with the other. Some companies, facilities that report to the US, maybe their headquarters is in US, but they function in Atlantic Canada. If you're good with one, you're good with the other. A small part of this Z462 pertains to arc flash, right? And I'll mention that back in the 90s when they were reviewing this, the study, they came up with the fact that electrical lost time incidents, so anything, say there was an incident in an electrical manner, the lost time incident, it wasn't that guys were getting electrocuted, it was actually that their clothing caught on fire and continued to burn, and the employee was then, they were hurt that way, not through electrocution. So the standard itself, I like to call it a benchmark. It's our benchmark in Canada for, for your safety measures, whether that be a lone wolf contractor, right up into, massive facilities that have several electricians on staff. It's best standard. So the CSA, it's a consensus on best practices. It tells you how to do things properly. It is descriptive, not prescriptive. So it's not a law and it's not a code. Then you've got occupational health and safety, right? And their acts, and that it changes a little bit province by province. But most in the clauses, the act will include the word shall, the employer shall, or the worker shall. But it doesn't describe how to do things. It just tells you what you have to do. There's a three-part harmony that has to happen, right, for any effective safety program. You've got the standard, you've got the law, and then you have the plan. So a comprehensive safety program for all employees written by the employer is going to have these three things. Okay. So the standard, it can't be effective without the law. The law can't be effective without having something to explain how to do things, like the standard. And neither one of them can be effectively, done without clear policies that are enforced by the employer. That's based on the standard and the law. So the standard deals with proper procedures for safe work, justification of work, de-energizing circuits, lockout tag out, approach restrictions, shock boundaries, and arc flash boundaries. Lockout tag out's been around for a long time, but I've worked myself in industry as a steam engineer back in the 90s, early 2000s. This was before this standard was introduced. You've got millwrights, electricians, contractors. They're all A-type personalities. Nobody wants to shut the equipment down, right? Back then, guys would do things that, the supervisor wouldn't want you to shut down the piece of equipment. They'd want you to, somehow fix it without making it go down. And it's no longer acceptable. Back then they turned a blind eye to it. There weren't as many procedures in place. Now we have the standard that these companies should be following. So the CSA, the purpose itself, adding this in, is to change the culture of the electrical community that thinks it's okay to work live. In Canada, you think of issues like, say, a mine. Well, a mine has 2 mine shafts, right? We can shut one down. The hospital, the wing with all the babies in it. Well, move the babies. There's always a way that we can de-energize. And if not, well, that's when you need to really look at, well, why do we have to work on it live, right? Sometimes it's testing, sometimes you have to, right? But it's mitigating that and understanding, one, if you're not working live, you don't need this stuff, right? In the end, though, who's responsible for electrical safety? Employers, supervisors, absolutely workers, and health and safety committees. So in the standard itself, it'll review arc flash boundaries. There's approach restrictions. One thing that you want to look at is defining who a qualified person is. And qualified person down here on the right, bottom right, that's taken right from the standard, and it defines who is a qualified person. One who has skills, knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid hazards involved. I'm going to go back to my time in industry. I can think of times I was working with the electrician on staff in a mill I used to work at, and for sure I had absolutely no training. I was in, if you look up at the arc flash boundaries here, restricted space and prohibited space, we were often in there before any standard existed, right? Now that I'm hoping that same plant is that's no longer allowed. Here's another slide on boundaries for arc flash protection. And this is going to change depending on your site or your facility, but you can see you've got limited, restricted, and prohibited, right? And you can see the different measures in the clothing that the guy's wearing there. Types of arc flash. So there's four main types. The most of what we talk about are open air and arc in a box. Ejected arc and tracking arc, they happen, but they're more rare. So open air stabilized arc, that's one that this is what it looks like. It could be it could be conductors laying somewhere. There's a cover removed. Okay, so the flash can go really anywhere. The one that we most commonly see in industry would be this style here, where it's arc in a box. So arc in a box, because typically you've had the cover off, and there's 5 sides that are directing all this energy at you while you've got the box open. That's what we would probably encounter the most. Ejected arc, although rare, I mean, even myself in industry, I've seen twist locks blow off 30 amp, and not quite to this extent, but I've seen it. And the other one would be tracking arc. Although rare, it can happen. And the tracking arc is where you would have the flash occurs, but between air and moisture on your clothing and skin, the tracking arc goes up in your clothing. It can cause ignition of clothing, and this usually it happens under higher voltages. What causes an arc flash? Well, there's a lot of things that could cause an arc flash. Mechanical breakdown, accidental contact with non-insulated tool or other metal items. You could have, somebody's working over a bus bar and they accidentally drop a tool or something falls on it, and then you have a flash over. Anything conductive that touches energized components, dirt, dust, moisture, deteriorated cable and conductors, loose parts, poor maintenance, improper use of equipment. I use sometimes a general electrical contractor going to a site that maybe the panel hasn't been opened in 30 years. That's another thing. So that you might see out there where that panel has been sitting away. We had a case in Truro. A guy told me he opened up the panel and there was a piece of leather, some old piece of leather between the bus and the side of the enclosure. That was all that was keeping the bus bar from touching the side of the enclosure. So you don't know what you're going to see out there. Going back to what is it? When an arc flash happens, there's quite a few things occur. You've got this fire that happens. It's a fierce conductive plasma fireball. It can cause serious burns. If you've got exposed skin, you may get more than a suntan. You could have incurable burns. Toxic gases, right? Anytime you have metals and plastics that are flashing to a vapor, you're gonna, usually a lot of this is gonna be copper. And also the tendency to, gasp when we're surprised, the tendency to gasp, you could inhale, and that could cause incurable lung damage. The other thing I'm going to lead into, with regards to a pressure wave, when copper flashes to a vapor, it expands 67,000 times, right? As opposed to water at about 1,600. So it's an explosion. The pressure wave involved. An arc fault generates a tremendous amount of heat, and that expansion of the air, it can cause barrel trauma. It can cause all kinds of things to happen. It could also, you could have enough of a concussion that it could throw you backwards. You could be impaled by something else. Another one is shrapnel, because we had mentioned that arc in a box, that, you could get pieces of shrapnel coming at you. So, that's kind of what happens when the flash occurs, depending on the extent. Some food for thought, temperatures here. Skin temperature for a curable burn, 176 degrees. Skin temperatures causing cell death, 205. Ignition of clothing, 752. Burning clothing, 1472. Metal droplets, 1832. Surface of the sun, 9,000 degrees. And then we have arc terminals at 35,000. So give you an idea where an arc can be, how much heat that can generate. Arc flash clothing. So there's two types of FR out there and that you need to be aware of when you're looking for clothing. You've got flame resistant and flame retardant. So flame resistant is a garment that has inherent qualities that make it flame resistant, okay? Whereas flame retardant often is a term used to describe chemical substance that imparts flame resistance on a fabric, okay? So know the difference. There's a couple other things you should look for when buying Arc Flash clothing. The material should be inherent, FR. Arc rated, written right on it. It'll often be on the if it's a shirt, it'll be on the collar. It'll be inside the breast of a coat. It'll be on the pants. It'll be towards the back or the side. Buttons and zippers should be properly protected. The thread used, and this goes for hemming or shortening, any alterations, logos. The thread must be FR. Okay. Arc Flash clothing, another thing that comes up is these abbreviations here: arc thermal protection value and energy break open threshold. So arc thermal performance value, that's the incident energy on a material that results in a 50% probability that sufficient heat transfer through the specimen is predicted to cause the onset of second-degree burn injury. So it's basically it's a measurement that they do. They test all these clothes before they go out, and that's what that ATPV is. But the ATPV, when you see it on a tag, all good clothing is going to have the ATPV, and it'll be in calories per centimeter square. We're going to go over what calories are in a moment, but all good clothing is going to have an ATPV. The next one down, EBT, the energy break open threshold, that's the incident energy on a material that results in a 50% probability of the break open. And that's defined as an area of at least 1.6 centimeters squared. So they actually blast the clothes until it blows apart. Here we see on the left 100% cotton versus a hazard risk category 2. This is going to be a minimum 8 calorie. So we have an explosion happen, and here this is a great picture. The guy on the left who's not properly protected, he's not doing so well. Here's some more extreme explosions. The two pictures on the left. So the guy was wearing a smock, and his clothing underneath, he wasn't wearing any Arc Flash clothing underneath. He was just wearing a protective smock. The explosion occurred. And you can see when they took the smock off that the explosion went up underneath his garment and got him in the chest area and the stomach. On the right, this guy was wearing FR jeans and FR shirt, and you can see the level here, right? What's a calorie? Well, for any of the count calories, it's the same thing that you'd see on food. Approximately 1 calorie is the heat energy your finger receives if you hold a cigarette lighter. If you hold your finger over a cigarette lighter for 1 second, that's the equivalent to 1 calorie. 1 second duration, 1.2 calorie per centimeter square of heat can cause a second-degree burn. So table method versus assessment. So this pertains more to facilities or general contractors that don't know what they're, they have an idea what they're going to be going to do, but they really don't know. So if you really don't know, you got to look at the tables in the CSA Z462. This is critical. Assessments, they go through all this and they define it. But when you have an assessment done on a facility, the engineer's going to put a sticker or a stamp. They're going to tell you what clothing you should be wearing for that application. So the table method, what it does is it gives you, it gives you an idea of what the work is being performed, and it gives you an idea of what to wear, right? That's in the case where you don't have an assessment done. So you might have heard me say hazard risk category. You'll also see it as an acronym HRC on some tags on some clothing. So what we see most of in industry is HRC2 and HRC4. So that is, let's see, And you kind of see here how they're getting heavier clothing as you go on through 1, 2, 3, and 4. You can also see the relationship, say in category 2 here. The minimum arc rating is 8 calories per centimeter square. Tells you what you should wear. Same with 3 and same with 4. So 2 and 4, that's what we see the most of. You can see at 3 and 4, these are commonly referred to as the beekeeper suits. A 40 cal is what we see the most of, though, in our marketplace. This is acceptable. This is not acceptable. So cotton underwear, no mankinis, okay? Guys, just trying to keep you all awake. Arc flash clothing, frequently asked questions. Can I get a short sleeve shirt in workwear? No, it would be an undershirt and you can't use it. You can use it as an undershirt and it's rated, but you can't use it for work. I work in a 20 kV environment. What kind of suit should I get? Well, give me a call and I'll help you try to digest the standard. I don't tell you what you need, and same with you distributors out there listening. You don't tell the customer what he needs. He has to tell you. So we guide him to the standard, and he reviews the standard, and then he tells us what he thinks he needs. Can I just guess what I need? No, can't guess. Can I just wear the overalls? It's too hot in here. Yeah, no, you can't just wear the overalls. You're only protected as your least protected area. So say in this case, I've just got the overalls on and they're a 40 cal overall. My rating is 0. I'm only as protected as my least protected area. I'm the experienced guys. Well, we always have those guys, and I just kind of put it here in big letters on the bottom. I've been doing this for years in jeans and a sweatshirt. I don't need this stuff. This is usually coming from a person within 5 years of retirement. Back up to the questions. Why don't my gloves have an arc rating? Well, we can get arc rated gloves, but 95% of what we see in industry is a voltage rated glove. So all the gloves that we have are voltage rated, and we're going to review those in a minute. Can I get a hood? Or sorry, can I get a fan on my hood? Absolutely, you can get a fan on your hood, and you can also have lighting on your hood. The benefit of a fan, 1, it cools the guy down. 2, it keeps the face shield clear. 3, in the event of a flash, it has a positive pressure in the hood. So you're less likely to ingest or inhale any vapors if you so incur a flash. What's the guarantee on UltraSoft? UltraSoft has a lifetime guarantee for the life of the garment. So UltraSoft and most arc flash clothing, they have a life. It's like wearing denim, really. So, you know, jeans, obviously, they can be worn out, but you're basically looking, when you're looking at the material, for wear or tears, right? But UltraSoft says that as long as it's within its lifespan, that it's going to be always FR rated. You can't take that quality away from it. How do I wash the suits? Regular detergent, no softeners. Oh, and this is backing up to those guys that, you know, doing jobs in t-shirts and jeans. Nothing ever goes wrong when you're experienced. So the gloves. Any of you that don't know how to measure a glove for the size wise, you just take a tape around the palm, not including the thumb. For this hand size here, I would go with a size 11. So where it's a little bit more than 10, I would go to an 11, size 11. Our gloves come in multiple sizes, multiple voltage classes, and we can also have different size cuffs available. Here's the voltage chart. So you see here on the left, all the classifications, 00 on through 4. Your AC test volts, that's what they're tested at. Your use voltage and your use volts in DC. Your label color. And all gloves, they're going to have that label. It may not be by that manufacturer. There's several manufacturers that use the same labeling. That's a standard out there. Okay, when you have to get your gloves tested, CSA recommends you get your gloves tested every 6 months. When you send them back, no matter whose gloves they are, wherever you send them, here's what they're looking for. They're looking for cracks, pinholes, cuts, and abrasions. Also the thickness and the ozone damage. The way they test the gloves, they actually fill the glove with water, and then they put it in a container of water, and they stick a probe down into the glove, and there's current sensors all on this tank of water, and they run current through the glove, through this probe. And the current that leaks through the glove, they call it the leak current. And there's an acceptable amount of leak that they can have. If it passes, it passes. If it fails, it fails. Cleaning and storage of your gloves. You can wash them in warm water with mild detergent. And then you can use some chlorine bleach in water to disinfect. Air or tumble dry, low heat, and you can dust them lightly with some talc to reduce the tackiness of the glove. Rubber gloves, a lot of guys, I see this being done, a lot of times guys are laying their gloves down. The gloves should be hung in their storage bag. So rubber insulating gloves should be stored in a glove bag, fingertips up and hung, not laid flat. All glove bags have a hook on the top that you can hang them. Keep them out of sunlight, keep them cool. Tools. Tools need to be tested at the CSA 60900. 1 kV tools should be double insulated. Double insulated should be 2 colors. That way, if you drop a tool and it gets a nick, you can see the other color. You know that it's time to throw that tool away. These are the manufacturers that Catalyst Sales and Marketing deals with. DuCap, PMMI International, Fuse Tech, and Little Fuse. I'll also mention that we talk mostly about Arc Flash clothing, but there are also other ways to mitigate flash via either fusing or detection devices. These are things that we can help you with. You can get in touch with us through Instagram, Facebook, LinkedIn, and our website, catalystsales.ca. You can also you can join us if you so desire next week for a continuation of our webinar series. Next week we have the shift towards electrification and the greenest form of heat. Before I open up for questions, I just want to mention again, I can't stress enough that any good safety program should have CSA Z462 at its core. Again, this isn't a certified webinar that we're doing here. This is just a general information session on Arc Flash. Thank you